So good evening, student. Today we will start the next one, quantitative analysis. So yesterday we have seen that what is RF and how can it could be used, that we have seen. Okay. Now today we are going to see the qualitative analysis. So the organic compound, you can, so are able to hearing my voice? Those who are in the online?
Yes, sir.
So when you have given the organic compound you have to analyze. Organic compound means carbon you have. Other than that, you have hydrogen, nitrogen, oxygen, halogen, sulfur. So when carbon and hydrogen is there, means hydrocarbon. When carbon, hydrogen along with oxygen, organo-oxygen compounds. So how we are classifying that organic compounds? We are classifying into hydrocarbons and organo-oxygen compounds. Then organo-nitrogen compound. So this organo-hydrogen compound, it comes for alkane, so alkane, alkene, alkynes. So these are aliphatic. Other than aromatic hydrocarbon. Hydrocarbons. And then organo-oxygen, you have alcohol, ether, aldehyde, ketone, acid, ester, acid halide, acid anhydride, acid amide. So this we call it as amide. And then organo-nitrogen compounds, you can say amines, nitro compounds, amides. Amides, it may be mono, di, like that. Okay. Then what else I have missed? Amide, nitriles. So this coming under the organo-nitrogen compounds. So it will contain. Now you have the compound, whether the compound is containing special element like nitrogen, phosphorus, sulfur, halogen, that can be, you can estimate using qualitative analysis. So in the qualitative analysis, we have the Lassine test. So what you are going to do in the Lassine test, you have to take a sodium metal, okay, small piece of sodium metal that you have to take in the fusion tube. Fusion tube means you can fuse it, okay. Then you have to introduce the flame, that sodium metal will be activated, and then you have to put the organic compounds, okay. You have to heat for red hot condition. Red hot condition. So once heat, after heating, you have to plunge it into water. So what happened during that, when the nitrogen will mix with that, okay, then you have to ground well, heat and filter. So this extract is known as Lassine extract. This extract is known as Lassine extract. Now this Lassine extract you have to take a pot. So first part is for nitrogen. So you can take the extract. So you add extract, you add the freshly prepared ferrous sulfate if you are getting, and then dilute or concentrated H2SO4. If you are getting the blue color, presence of nitrogen. So how you can say the equation wise? So you are putting that sodium metal, and the sodium metal plus carbon plus nitrogen. This is from the organic compound. What are the organic compound which contain nitrogen? Amide, RCONH2, amine, RNH2, or nitro compound, RNO2. So you are getting the compound carbon from the compound, nitrogen from the compound. So this sodium metal will pyrolyze. Pyrolyze means it will convert to atoms. So it gives, when it makes, it gives the NaCN. So now this NaCN is a water solid. Okay, in that extract what you have? Sodium cyanide. Then the sodium cyanide, okay, if you are treated with ferrous sulfate, if you are treated with the ferrous sulfate, it will form first FeCN6 4 minus hexacyanoferrate. Okay, again if you are adding ferric chloride Fe3 plus, or you are adding concentrated sulfuric acid, that sulfuric acid can oxidize Fe2 into Fe3 plus. So then you have the water molecule in that system. So ultimately it gives the ferrocyanide Fe4 FeCN6 thrice into XH2. So this is known as Prussian blue. Prussian blue. That's why you are getting blue color in the solution. So what you have to do? You have to prepare extract. In that you have to add ferrous sulfate and then concentrated sulfuric acid, which you are getting blue color, presence of nitrogen. And then for the test for sulfur, suppose the compound which contain nitrogen and sulfur means you can do this test. So what will happen? Sodium metal, carbon, nitrogen plus sulfur. So from organic compound, it gives NaSCN, sodium thiocyanate. Prepare sodium thiocyanate. This is sodium cyanide. So it will be in the parts per million. That may be 1 milligram in 1 liter or 10 milligram in 1 liter, like that only, not more than that. So then you are proceeding and then you are adding ferric chloride. Okay, so it will give FeSCN thrice 2 plus 3Na plus. So trithiocyanato Fe2 plus Fe3 plus. So it will give blood red color. Blood red color. Okay. In the cinema industry, they will use ammonium thiocyanate with the ferric chloride. And the ferric chloride they will paste, and then they will paste again one more ammonium thiocyanate. Immediately it will give the blood color. This is what they are using in the film industry. Suppose your compound having test for sulfur along with nitrogen means the above test. Okay. Suppose only you have the sulfur means sodium metal plus sulfur from the compound, from organic compound. It gives organic compound. Na No. So it will form sulfide. Verum sodium sulfide only it will form. Okay. NaCS வேண்டிய அவசியம் கிடையாது. அது இல்லாம இது ஃபார்ம் ஆகாது. It won't form. So it will form only sodium sulfide. Okay. So once it forms the sodium sulfide, this is called sodium sulfide. So this sodium sulfide, when you treat with lead acetate, so PbCH3COO twice. This is called lead acetate. That's why you are getting Pb2 plus. From here only you are getting Pb2 plus. So it will be precipitated lead sulfide, then Na2 plus. Okay. This is the block precipitate. So one more test is there. So how to find out? So this is one test. Suppose if you are having sodium sulfide, that sodium sulfide treated with sodium nitrocrucide. It's one of the complex. So the name of formula of complex sodium nitrocrucide. So what is the name? Sodium nitrocrucide. When you are putting, so you will end up with the new one. Na4 Fe CN6 CN5 times NOS. This violet color indicate presence of sulfur. Okay. Suppose if you have the halogen, test for halogen. When you have sodium metal, when it react with the halogen from organic compound, so it gives NaX. This NaX, when you treat it with AgNO3, so the X may be chloro, bromo, iodo. Chloro, bromo, iodo. Then you will get the 3 different precipitate, that will be AgCl, AgBr, AgI. Okay, so you will get the white precipitate. This is pale yellow precipitate, and then yellow precipitate. So now, how could you find out whether it is a chloro, bromo, or iodo? So when you have like this situation, if you are putting ammonium hydroxide, if it is soluble, it becomes AgCl. If it is partly soluble, AgBr. Insoluble, it become AgI. So from this we can very easily what are the halide they are having in this organic compound, and then test for phosphorus. When you have the sodium and then phosphorus from organic compound, and it will form the sodium phosphate. it will form the sodium phosphorus. Generally, the phosphorus is detected by fusing the organic compound with oxidation agent sodium peroxide. Okay, so not with your sodium metal. So generally with the sodium peroxide. So the phosphorus in the compound oxides into phosphate. Okay, by using sodium peroxide, and then extracted with the water. Again, the solution is boiled with HNO3 and treated with ammonium molecule. So the sodium, instead of sodium, we have to use Na2O2, sodium peroxide. So the phosphorus get oxidized into PO4 3 minus. Okay. So now this you have to treat with the HNO3. When you are treat, it becomes H3PO3 plus NaNO3. So the 3HNO3 and 3NaNO3 will get it. Now this H3PO4 phosphoric acid. This phosphoric acid, when you are treated with ammonium molybdate, so you are adding HNO3 and then to that only you are adding ammonium molybdate. The ammonium molybdate formula is NH4 twice MO4. MO4. Then when you are treating this with along with the 21 moles of HNO3, 12 moles of ammonium molybdate, you can end up with end up with NH4 thrice UO4 12 MO3 plus ammonium nitrate into 1 ammonium nitrate plus 12H2. So this is ammonium phosphomolybdate. Okay, you will get the yellow precipitate. By this way, you can find out the qualitative peak. Qualitative means you are finding whether it is present or not. Okay, so this is how they are finding out. So the sodium peroxide equation is there now. That becomes Na2O2 plus 2 phosphorus. It gives 2 Na3PO4 plus 2 Na2O2. So this Na3PO4 only, again you are putting HNO3 and ammonium molybdate. The HNO3 convert sodium phosphate into phosphoric acid. This phosphoric acid reacted with ammonium molybdate. It gives ammonium phosphomolybdate. So that ammonium phosphate, so here is the no phosphate group. It gives the yellow color. Okay, that solution, this solution become colorless. Ammonium molybdate solution become colorless. Once if you are adding, if the phosphate is present, so between the ammonium and molybdate, the phosphate will be added. Okay, so the ammonium phosphomolybdate will forming, that will be yellow in color. Okay, and then quantitative analysis. So quantitative analysis can be done by the or otherwise elemental analysis. So now very easier methods are available, but in the older days the percentage of carbon and hydrogen was done by using copper oxide method, and the percentage of nitrogen was done by using Dumas method, and then Geljar method. Okay, halogens are done by the Gary's method. Sulfurs are done by Geljar method only. So the oxygen, which will be 100 minus sum of all other elements, then it gives the oxygen. So now, so what is the quantitative relationship that we will take? So percentage of carbon is equal to 12 into W2 into 100, then the whole thing divided by 44 into W. So W is weight of organic compound. So in this method, what they can do now? So they will take organic compound, they will burn in the excess of oxygen, and it will pass through copper oxide. So when the carbon and hydrogen present in your organic compound, which will be oxidized into carbon dioxide and water. Hydrogen become water, carbon become carbon dioxide. So how much amount of mass of water and CO2 produced by using the calcium carbonate tube and the copper oxide tube, they will measure. Copper oxide is a colorless white. When the water is hydrated, then it becomes blue color. So how much initially the copper oxide tubes, what is the weight? After the reaction, what is the weight? So what is the difference between that? It gives the weight of copper sulfate, okay, and water, and then carbon, which will be converted into carbon dioxide. So that also measured. So percentage of carbon is equal to 12 is the atomic mass of carbon. W2 is how much amount of carbon dioxide produced. So Abdelina, weight of CO2 produced. Okay, 44 is the carbon dioxide molecular weight, 12. So atomic weight of carbon is 12. Okay, then molecular weight of carbon dioxide is 44. Now it's clear, no? 12 by 44. W2 is in that reaction, it will produce carbon dioxide. What is the weight of carbon dioxide? That divided by weight of how much organic compound you have taken and 100. And then percentage of nitrogen. Same method. So percentage of hydrogen. So what is that? Hydrogen means 2 into same way W1 into 100 percentage, that's why 100 divided by 18 into W. So molecular weight of water is 18. Okay, in the water how many hydrogen is there? 2. That's why you are putting 2 hydrogen. The water you have 2 hydrogen, no more. 1 plus 1 2. So the atomic weight of hydrogen is 1. Hydrogen molecule coming now, that's why we are putting 2. So W1 is the weight of water produced. No, water. W is the weight of organic compound. So the hydrogen gas will explode now. That we can't decide. Okay, it will be very, very lightweight. So this method you can calculate. So this is the formula. Simply I will tell. So the carbon is converted into carbon dioxide. Am I right? That's why 44. 12 is the molecular weight. So whatever compound you are taken, in that it converted something. So converted divided by taken into 100 use. So same way, 2 hydrogen and 18 is the molecular weight. W to water is converted. W is taken organic compound into 100. That's all. Okay. And then percentage of nitrogen. Percentage of nitrogen. So in the nitrogen method, the formula little difficult. Percentage of nitrogen is equal to nitrogen is 24. N2 is 28. 14. Nitrogen is 14. 14 plus 14, 28. So they are calculated in the standard temperature and pressure. Okay. That's why 22,400 into W into V into 100. So now tell me what is the V? Volume of N2. That's why V. W is weight of organic compound. So we know that in STP, okay, in STP, volume of nitrogen is equal to P1V1 into 273 divided by 760 mmHg into T1. Let B is ml. So this is that, okay, when you are calculating volume. So then if you are calculating VML of N2 at STP means 28 into V divided by 22,400. Therefore, VML of nitrogen at STP weighs, so 28 into V divided by 22,400 grams, because 22,400 ml nitrogen at weight of weighs 28 grams. It's okay. So this is one method. Another method, Kelcher. So this is from mass method. Then Kelcher method. Kelcher method. So the compound is heated with sulfuric acid. So the nitrogen will be converted into ammonium sulfate. Okay. So the nitrogen from organic compound and then concentrated H2SO4. So it will convert it to ammonium sulfate. So this ammonium sulfate is heated with sodium hydroxide. Then it becomes sodium sulfate. So this sodium sulfate, or otherwise nitrogen plus hydrogen gives ammonia plus H2SO4 gives ammonium sulfate. H4 ammonium sulfate. So again, this sodium hydroxide plus H2SO4 gives sodium sulfate. So from this method, we can calculate percentage of nitrogen equal to, what is the atomic mass of nitrogen? 14 into M into 2 into V minus V1 by 2 divided by 1000 into W into 100. So we have to give the meaning for that each and every equation. So atomic weight of nitrogen is 14. Capital M is molarity. Molarity means what? Weight per liter divided by molecular weight. Weight per liter divided by molecular weight. Weight per molecular weight gives the moles. So that in the 1 liter, it gives the molarity. Okay, weight per liter divided by molecular weight gives the molarity, or otherwise number of moles divided by volume of solution. Okay, and then B is volume of H2SO4 taken. So B1, some amount of H2SO4 consumed, no? Remaining H2SO4 we have to titrate against the sodium hydroxide. So that is volume of NaOH used for the titration of excess H2SO4. Because in the reaction, look here, compound plus concentrated sulfuric acid, it only converted ammonium sulfate. Okay, so that you are reacting with sodium hydroxide, the excess H2SO4 become Na2SO4. Okay, and then remaining ammonium you are having. That ammonia against H2SO4 combined, it will give ammonium sulfate. So you are measuring this sodium hydroxide used for how much excess amount of sulfuric acid present. If it equal amount means it will only convert ammonium sulfate. After the ammonium sulfate, you won't react. So that's why V1. That 2 into V minus V1 by 2, it gives volume of NH3 solution. So during the reaction only NH3 produced, right? You are not taking directly NH3. So you have to calculate by using this. And you know that W is the weight of organic compound. Weight or mass of organic. Okay. And then percentage of halogen. So percentage of halogen general formula, percentage of X equal to atomic mass of X to W1, this X and this is multiplication symbol divided by molecular mass of AgX into W into alpha. So percentage of chlorine. So chlorine means what is the chlorine weight of? What is the chlorine weight, ma? 35.5. So 35.5 divided by molecular weight. So 143.5. Okay. Into W1 into W into 100. Okay. So bromine you have to put like this. Bromine percentage of iodine. So you can work it out yourself. So what is that silver bromide weight? So that silver bromide. So 187.77 into W. Silver iodide. Silver iodide is 234.77 into W into 100. Atomic weight of bromine. So 79.9. Atomic weight of iodine 126.9 into W. So by which you can calculate the percentage of halogen. So one more thing, what we have left in this unit, the phosphorus and halogen. If they have completed, everything over. Percentage of phosphorus. So in the phosphorus method, what they are doing now, they will take the organic compound and heat it with the fuming nitric acid. So the carbon and hydrogens are oxidized into carbon dioxide and water, and then phosphorus is oxidized into phosphoric acid H3PO4 as like in qualitative analysis. So then they will put that precipitated using ammonium molybdate. Okay, so the precipitate is filtered, washed, and dried. How much precipitate is formed that they have taken. So for this, so they have converting phosphorate into phosphoric acid. When it react with ammonium phosphate, ammonium molybdate, it gives ammonium phosphomolybdate. So this is the ammonium phosphomolybdate. So this will become the yellow precipitate. This precipitate they have to filter out. Okay. Then they have to weigh how much weight is formed. They have to measure. Now, percentage of phosphorus equal to the atomic weight of phosphorus in phosphate is 62. So atomic weight of phosphorus is 30. When it combined with PO4, it becomes 62. Okay. So once if your atomic weight is 30.9, then you can take the 31 into how much amount of the ammonium molybdate formed into 100 divided by the molecular mass of ammonium phosphomolybdate is 1877. So 1877 into W. So it will give the percentage of. For the sulfur, we didn't calculate it. Yes, we will do it. So this is the way by which we can do. And then percentage of sulfur. So sulfur, same way, they will use with the sodium peroxide or fuming nitric acid. So the fuming nitric acid oxidize sulfur into H2SO4. So once H2SO4 is added means they will add the barium chloride solution. The barium chloride will be precipitated as barium sulfate. They will filter. From the weight, they will calculate how much sulfate is present. So, percentage of sulfur is equal to 32 into W1 into 100 that divided by 233 into W1 because barium sulfate molecular mass of barium sulfate is 233. Okay. So sulfur will be present in the 32 gram. That's why they have taken 32 by. So it gives the percentage of sulfur. And then phosphorus over oxygen. So percentage of oxygen. It gives. So percentage of O2 gives 100 minus sum of percentage of all other elements. It gives 100. Okay. So generally, what is the formula of O2 is equal to 32 into W1 into 100 divided by 88 into W. Simpler. So O2 this it comes from oxygen. 32 is O2. 16 plus 16. Okay. And then 88. 88, what is the 88? So 32 grams of oxygen, which is obtained from the you are converting carbon into carbon dioxide. No, that time only oxygen used. So what they will say, 32 gram into W1 divided by 88 of oxygen from the carbon dioxide only. No, that's why they have taken 88 because they have used 2 moles of carbon dioxide. 2 into 44, it gives 88. So that's all about the percentage of oxygen. So now we work it out the problems. You have time, no? Time is there or not? So you have to answer, no, all of you. So writing the compound CH2 double bond C double bond CH2 CH2 double bond C double bond O. Okay. CH3 CHOH CH3. Okay. So first one, you tell me what is, so you have to identify hybridization state of each carbon. What is the hybridization of this carbon? How it is sp3? It become sp2. What about this? What about this? Then what about this? This? For this? Those who are in the online, you can answer. What is the hybridization of this carbon? What is the hybridization of this carbon? For this? Yes?
SP.
SP? SP? So it attaches 4 groups. What about this?
SP3.
For all the carbon atom in the benzene ring is sp2. Since you know that all are attached with one hydrogen. So it attached with 3 carbon. So each carbon in the benzene ring is sp2 hybridization. So don't forget it. Now you tell me what is the hybridization of this carbon? This carbon. Next one. Only sp. That is 1, 2, 3 carbon. Then this one. This one. That is 2 carbon only, no, 2 atom only, no. So please remember the carbon attached with 4 atoms or group, and it is sp3. So the carbon which is attached with 3 atoms or groups, carbon attached with 2 atoms or groups, then it becomes sp2 and sp. So please remember. Very simple. You can find out very easily. Okay. So this is the way. Next, you have to identify the functional group present in the compound. I will write the sum of the compound. You have to tell what are the functional group present. So now tell me the first one, what is the functional group present? This one. Anybody in the meet? Tell me. Tell me what is the functional group present over here? So here we have the functional group like this. COO dash. Then it becomes ester. Please remember, ether means the oxygen which will attach to carbon, not carbonate. Okay. So tell me here, what are the functional group? This carbon. This one. Alcohol 1. Ether 2. This one now. Alcohol OH. Ether O. And the next one is acid. So you have to say carboxylic acid. The carbonate group attached with OH. Now you tell me here. Tell me here. NO2, nitro. Then carbon double bond, alkene. Okay, so you have to identify. First, you should know the functional group. So remember, you classify the compound like this, then it becomes easy. Okay, CnH2n plus 2. So this will become carbon-carbon single bond, and this become carbon-carbon double bond CnH2n. This become carbon-carbon triple bond. This become CnH2n minus 2. Then aromatic hydrocarbon, it will contain benzene and their analogs. Alcohol, you have the functional group of OH. Ether, oxygen. Aldehyde, COH or CH2. Anything you can say. Ketone, you have only carbonate with 2 carbon. So generally they will write CO. Acid, you have COOH. Otherwise, COOH. You can say. Ester, it becomes COO dash dash. Inga oru carbon, inga oru carbon. So that's ester. So general as COO dash. And acid halide, COX or COX. Acid anhydride, COOCO. So this will become COOCO or CO twice. Acid amide become CONH2 or CONH2. That's what they will mention the amide. So nitrile become cyanide, C triple bond N. Okay, amide become CO, NH2. Nitro compound become NO2. Amine become NH2. NH2, NF, single bond pressure amine, primary amine. So we have to remember the function. Sorry. Identify the reagent whichever shown in the bold in the following equation as nucleophile and electrophile. Okay, I will write the equation. You need to identify. CH3 COOH plus. So whatever I'm writing in the red letter, you have to identify. That is what it gives. CH3CO CH3 COO minus plus H2. Then CH3 CO CH3 plus CH3 to tell me what is the rate in the first case, nucleophile, electrophile, or free radical, or base. So this will become nucleophile. What is the meaning of nucleophile? Why could you consider that? Okay. So it become base because it abstract the proton, no. That's why it is a base. In the second case, nucleophile. Third case, so you have to draw the resonance structure for phenol. Who will draw? Who will draw the resonance structure for phenol? Will you? You draw it here itself. It's wrong. No. Then how you can? Use different color to show the error mark. See, the lone pair coming over here now. That means it gives the electron. This one get polarized, so it goes to this side. This part. This part. Go to this part. Just you put it in the top. Now, what happened? It given the electron to here. Then you put the no. So wherever W and they are going now, that's it. So now, what is the charge of this carbon?
Plus.
Oh.
Minus.
See, taking plus O. And it on plus O. When it gives minus. So now, how you will get this? How you will get the quantity of the one? Here only you have the one left. First you are negative, then the electron bonds are same, you know. You have bond over here, not here. Take this side. Let's put bond over here. Now what we have is your line. So when it minus, you have to put the 2 arrow one. Suppose if it is plus, you will not put the 2 arrow one. You will put only 1 arrow. Okay, and now you migrate this into this bar. And here is you put 1 more arrow. Now what happened? Here double bond, double bond OH plus. Here double bond, then positive. The negative. Next, what will happen? This will go here, it will go here. Correct. No. Back. Minus. Here minus. Double bond. Now this minus should be here. Then move to the power stage. No, one more arrow. One more arrow. So that minus go to the positive side.
In the double bond only.
Double bond like electron of the opposite direction.
And then
Same.
oxygen couple.
Writing the resonance go to the order. No. Double bond. Double bond. Double bond. OH. Correct? So you started here. If you are drawing from here, you will end up here. Okay. Only one resonance sector I am drawing, and then I will show the difference between. So always you have to put the symbol like this. Suppose if you have benzaldehyde. That's it. The resonance is this red colors. And oxygen has to do. So she started from here, then she ended. Let's say.
Every
Okay, so you started here, ended here. So look this, we have only 1 year now. When minus coming now, that can be put to year now. And electron release. That's why you get 2 year. Whereas the electron return, here, got it? Okay. Plus, next plus is redox reaction. Okay, for all of you, can leave.
Thank you, sir.